Hello everybody, welcome to another lesson by me, Miss Pythagoras. In this lesson, I will explain Euclidean geometry, how to prove triangles similar. This is part 1. I will also show you the formal proof of the theorem as well as 3 examples. This is lesson 3 of 11. Two polygons or triangles are said to be similar if the following conditions are true. The corresponding angles of the polygons are equal and the corresponding sides of the polygons are in the same proportion. The symbol we use for similarity is 3 vertical stripes. Let's look at the theorem. If two triangles are equiangular, then their corresponding sides are in proportion and the triangles are similar. Now, when we do a proof, we always start with the given part. And the given part is triangle ABC and triangle DEG with angle A equal to angle D, angle B equal to angle E, and angle C equal to angle G. The required to prove is that AB, the ratio, over DE is equal to AC over DG is equal to the ratio BC over EG. Then we have to make a construction, and our construction is we will draw HI such that AH, the length, is equal to DE and the length AI is equal to DG. Now here's the proof. We start with, in triangle AHI, that's the little triangle inside the big triangle, and the other triangle, and triangle DEG. AH is equal to DE. That was our construction. Angle A is equal to angle D. That was given. And AI is equal to DG. That was also the construction. Therefore, we can say that triangle AHI is congruent to triangle DEG. And the reason for the congruency is side, included angle, and side. Then we know that angle AHI is equal to angle E and equal to angle B. So it's this little star at H is equal to the star at B. And because they are equal, we can say that HI is parallel to BC. Why? Because we find corresponding angles equal. And now that we know that HI is parallel to BC, we can say that AB over AH, the ratio, is equal to AC over AI. And the reason is line parallel to one side of a triangle. And furthermore, we know that AH is equal to DE, that was our construction, and AI is equal to DG, that was the construction. Therefore, we can say that the ratio AB over DE is equal to the ratio AC over DG. And similarly, it can be shown that AB over DE is equal to BC over EG. Therefore, triangle ABC is similar similar to triangle DEG. Example 1, where we have to calculate with reasons the length of SP, and that is what we're looking for. So we will work out the length of SP by proving the two triangles similar. So let's start. In triangle PQS and triangle KLM, we can see that angle Q is equal to angle L is equal to 49 degrees. That's given. Angle S is equal to angle M is equal to 52 degrees. That's also given. Therefore, without thinking, we can say that the third angle, P, is equal to K, and your reason will be angles of a triangle. Then, now that we know that the three angles are equal, we can say that triangle QSP is similar to triangle LMK, and the reason angle, angle, angle. And then I just want to focus your attention to this part over here. Can you see I wrote the triangle's name as QSP, and that was the order in which I found the angles equal, QSP. And then on the other triangle, can you see the order is LMK, because LMK, that's the corresponding angles that are equal. So now that I know that the two triangles are similar, I can write down the ratios, and I can write, I do the McDonald's bit. So that means you can say that QS over LM is equal to the ratio SP over MK is equal to the ratio QP over LK. And your reason is because the two triangles are similar. So we are looking for the value of PS or SP. So it's this one. Now let's see. We know the length of QS, we know the length of LM, and we know the length of MK. So this is pi for now. So this is what we're going to use. Now we will substitute. QS is 5 over LM is 9 equals SP is what we're looking for, and MK is 7. Then you can multiply the 7 away, both sides, and you end with 5 over 9 times 7 is SP. Therefore, SP's length is 3,9. Before we continue, have you subscribed yet? And a reminder, you can also visit my website, onlinemaths.co.za. The link is in the description below. Also feel free to leave a comment or like my video. Let's continue with the examples. Example 2. In the diagram below, HJ is a tangent to the circle at J. Prove that at number 1, triangle FJH, that's the big triangle, is similar to triangle JGH, and that's the blue triangle. Now, in order for us to prove two triangles similar, we need to find three angles equal. Now, it was given that HJ is a tangent. That's a very important bit of information. So then we can say that angle F is equal to angle J1. And our reason, the angle between the tangent and the chord is equal to the angle in the opposite segment. Then angle H is equal to angle H since it's the common angle. Therefore, without thinking, we can say that the third angle of each triangle is equal to the other angle. So we can say, therefore, angle J is equal to angle G, and your reason, angles of a triangle. Then we can write, therefore, triangle FHJ, can you see the order? FHJ is similar to triangle JHG, and your reason, angle, angle, angle. Then number 2 wants us to write down, or prove rather, that HJ squared is equal to HG times HF. Now where does that come from? That comes from the fact that we could prove the two triangles similar in number 1. So we know that the two triangles are similar. And because they are similar, we can write down the corresponding ratios. Therefore, we can say that FH over JH is equal to HJ over HG is equal to FJ over JG. And our reason, the two triangles are similar. So now there's a lot of information there. So let's see. This, what we need to prove here at number 2, says HJ squared. That means there's two HJs. Now let's see. This one is HJ, and this one, although it's JH, it's still HJ. It's the same thing. And then equals on the other side HG, which is that one, times HF. HF is the same as FH. So therefore, we will use the 2 there, and this one is by for now. So what we will do is, and then there's the McDonald's thing flying in, which is not necessary anymore. So now we can say that these two, when we cross multiply, times with those two, and we end with FH times HG is equal to HJ times HJ, and this times that will be HJ squared. Example 3. In the diagram, prove that triangle PQT is similar to triangle SQR. So we need to find 3 angles equal to prove 2 triangles similar. Let's start. In triangle PQT and triangle QSR, we can see that angle P is equal to angle S, and the reason, angles in same segment. So P equals S. We can also say that angle T is equal to angle R. Again, the reason will be angles in same segment. Therefore, without thinking, the third angle will be equal. We can say Q2, angle Q2 is equal to angle Q1. Angles of a triangle, or you can use the reason, third angle of a triangle. Then we can say the two triangles are similar. Therefore, triangle PTQ is similar to triangle SRQ. Please note the order in which you write down the name of the triangle. And our reason for the two triangles to be similar, angle, angle, angle. Question 2 wants us to write down this horrible thing. So what we need is, we know that the two triangles are similar. Therefore, we can write down the ratios. And we can say, have a look. PT over SR is equal to the ratio TQ over RQ is equal to the ratio PQ over SQ. And the reason, the two triangles are similar. So what are we looking for? SQ, it's that one, times TQ is that one, is equal to PQ is that one, times RQ is that one. So therefore, this is pi for now, and then we have the ratios there, and we can simply cross multiply And we end with SQ times DQ is equal to PQ times RQ. In the next lesson, I will discuss part 2 of similarity. There, I will explain when corresponding sides of two triangles are in proportion, then they are similar. Click on the video in the left-hand corner to take you straight to the next lesson.